Hi, in this video, I'm going to show you my implementation of a binary search tree. In here, I used a linked list data structure, and my node will have 2 pointers, the left and the right. My tree will have a reference to the root node. Then all the supporting nodes will just be interconnected based on the 2 pointers. In the code, I have a class called node. It has 3 attributes, the data, the left node, and then the right node. My tree class has a pointer to a root node. So the insert algorithm is a recursion. It will take in a parameter node as a starting point. Well, in this case, it's always the root node. If the current node is null, then it will insert the value there. If it's not null, then it will start to check for the value. So if it's less than the current node value, then it goes to the left side of the tree, then continue on with the recursion until it gets a null space. Otherwise, if it's greater than the value, then it goes to the right side of the tree. So the next function that I'm going to discuss is the getMin. So the getMinimum is just to traverse through the tree until you don't get a left node below it. So it means that that is the least value in the tree. And then the opposite of it is the getMaximum, wherein you just continue on to go to the right side of the tree, and then if you don't get a right node below it, then it means that's the maximum value. So both of these functions are also using a recursive approach. Then the search node is similar to insert, where you just need to traverse to the tree and checking the value if you need to go left and right. But the terminal condition will be whether if you've encountered a match to the value that you're looking for. So of course, if you've managed to visit all the nodes as you go left to right, then if you don't get a match, that means it's either the value is not there or the tree is empty. Okay, then the next function is the get predecessor. So the get predecessor by rule is just the maximum of your left subtree. And then, so here you see the function call that if there's a then the node that you're trying to check for the predecessor of, you just need to get the left node of it and then use the function of the maximum that we have earlier to get the value. Then the successor would be the opposite. So the opposite is to get the minimum of the right subtree. In this section here, you start from the root node, and then you try to traverse down below up until you get a value that is, so in this case, if the successor is, if it's greater than that node. So this same logic also applies for getting the predecessor, which is also the opposite. So you're just going to the root, then as you go down, you just need to look for the value that is less than that that node that you're trying to search for. Okay, then lastly is the deletion. So the delete is basically what you do is you actually have 3 conditions here. So one is if you're working on a leaf node, meaning you don't have a children, then you straight away remove that and assign the pointer to the and free up the pointer to the parent node. But if you have if you have either 1 or 2, then what you do is actually you switch the value of that node to its predecessor, and then from there you get the minimum, and after you get the minimum, then you do a switch. Okay, so for the demo, just to quickly let me run this program if you don't have much time. So let's say I'm gonna do insert 5, insert 3, insert 1, then I'm gonna print it. There you go. Then I'm going to delete this tree and print it. Yeah. So that's it. Thank you.